as I said, that we're going to have one more session today for sensor data uploaded to the server. Okay, server is ready. So here's what I'm going to do. It is really tough to all together sensors and my laptop and Raspberry Pi and cameras from laptop camera to external cameras. Cameras quality is not really clear enough. So much difficulties. So what I am going to do is I'm going to give you a lecture, the full lecture tonight, and then the real hands-on that sensor wire connections, and wire connections are all done. Only something undone yet is uploading. Okay, so uploading will be separately recorded and attached to this Zoom record, and will be posted on the Blackboard. It will be, I can do that tonight, and will be on your Blackboard by tomorrow. So you may be able to review all the work. But you'll get the concept fully. The coding wise, I think a couple of statements needs to be added to your Python code when you collect sensor data and to send it to the server. Okay, so I'll give you a server address. Then server will keep your sensor data with your timestamps and your name. So later I can grade yours based upon the data that you posted. Okay. This is the first half of the techniques that we are handling in this semester. And after this slide, I posted another small slide, if you can see from your Blackboard, okay? And I am going to introduce to you how you can prepare for iPhone app developments, okay? And I'm going to give you a small demo that may motivate you to learn something about the iPhone apps. The amount of coding in iPhone apps developments is not really as big as, for example, Java. It's the coding amount wise, maybe similar to Python or a little less. The concept wise, maybe a little bit confusing initially, but if you practice it, then I think you will be okay. Why it is confused? Because everything is a graphics, okay? iPhone apps, Python, if you make a graphical user interface using Python, likely you have some additional work. But in iPhone apps developments, the graphical user interface is pretty much ready to cook. So you grab this from there, here, and then assemble them all, and then run it. Okay, so it'll be really fun. I hope you have that feeling as well. So I'll give you some introduction today. Okay, as I said, the real sensor wires and plug into the Raspberry Pi. I need to do that again in order to record the data collection and sensor data hosting on the server. Then it takes you guys already know, right? It takes forever. So what I do is I record it and I clean my recording and then post it. Okay, but the concept, all the techniques are on this slide. So if you are ready, your Python codes on Raspberry Pi, and of course your sensors are ready to capture, then we need to use some of the packages, which is a request. Okay, as I said here, this should be done on your Raspberry Pi, Linux. Okay, it's not on your the Windows systems.
Good night, Professor.
It should run on Raspberry Pi. Somebody tried to say.
I say good night, Professor Elvin Almonte.
Okay. Good night. Yeah. Okay. Okay. And then you can choose some sensors. Okay. You don't need to choose this humidity and temperature sensor, but I'm going to, on my record, I'm going to do a few of those. Okay. Last week on my recording, I've used this DHT 11 sensor. Then you have to work because the extra work file needs to be updated. The library that you imported for that the humidity and temperature sensor, Adafruit's company didn't update the library, so we have to update the library on our own. The updates has all the configuration up to Raspberry Pi Model 3, but those who have a Model 4, that's what I used the last week. So something happens, right? So in that case, you have to update the library manually. That's, I explained the Zoom, I mean the video last week, right? You can refer to that. If you do this, remember that this is a DHT sensor. This sensor has 3 pins, 2 pins for the power supply and ground, and then only one sensor, 1 line, 1 pin that is for the data. So you collect the data from there. This is a code given from that library. We didn't change this much, but something that you have to be careful is this Adafruit, this library is not ready for recognizing the pins that are designated from Raspberry Pi Model 4. So you have to fix it. Then you can use this. Okay. One thing that you have to be careful here is the PCM. Okay. This pin number is the PCM. Okay. You have to jump the cables very carefully. And only if you see this slide, then the statements is very simple, right? We do not have many. Oops. Is it this? Where is my? Where's my cursor? Okay. I tried to get a pen settings, but from my MacBook, it's not working. But anyway, I wanted to see my mouse movement. So import Adafruit IDT. If you're running on a Raspberry Pi Model 4, then you have to modify this a little bit. Only one file modification. And then define the sensor, okay? Hey, I'm going to use DHT 11, for example, okay? Or DHT 22, or AM 23 or 2, depending upon which sensor that you are using. And then GPIO, the pins that you need to define here, whatever the number here, that's a PCM number. And also you need to jump the cables into that proper pin number according to PCM mode. Next statement is to gather the data. Okay, this is an input to library. Read, retry, and then this function receives two parameters, two arguments, sensor and GPIO. Sensor we already says that is a DHT11, GPIO the pin number 4. Okay, then it can take humidity and temperatures data. That humidity and temperature will be printed. Okay, temperature and humidity is printed in this format. There's the first one. There's a floating point place 1 and same thing, 0.01 F. There's a floating points because it gives us some number. If you want to change this to decimal points plus 2, then you have 0.012, things like that. Okay, this is a very simple code. Print, gather the data, and then these two are 2 lines for setting up. Okay, but if you want to, so with that Python code, so you have to first run Python code to make sure that it collects the data. Okay, once your sensor collects the data and print on your terminal clearly. Clear means it's not because of the letter clarity, but the accurate data collected, then you can post it. Okay, this is an explanation that I just explained. The Adafruit DHT, you might have this error. There is a mismatch between library already developed and the device that we are using. So our device is a leading. So our device is one version advanced than the library. So what you need to do is you need to go to when you set up this library, okay, like PHP, PHP 3, there's a 3, right? And then Adafruit, DHT. Then it'll be installed on your, it is on this location. If your Python is a 3.7, then it'll be in this location, okay? So you need to go to this location. This is under your home directory, okay? So cd /local/library/python 3.7/site packages/adafruit_DHT. Then you can see this file, platform_detect.py, okay? Inside this Python file, you need to add this 3 lines. Actually 2 lines, right? The line in the middle, that is just comments. So somewhere in there, you can say elif match.group open and close parenthesis number 1 equals, and then BCM 2711. BCM 2711 indicates that you are going to use the Raspberry Pi Model 4. So without this, your Python code does not collect sensor data. Instead, it generates error messages. That's what we had last week multiple times, and then I fixed it, right? Okay, so data transmissions. We have a database, let's say somewhere, okay, remote database. And then the client device is our Raspberry Pi. So our client device has a sensors connected. So sensor collects data, then Raspberry Pi read it and send it to here in this database. So in between, you need to have some services, right? Usually it is the API service, right? Application program interface. So I developed that in PHP. You do not have to worry about, you simply use it, okay? But I'm going to explain it. So you access this API, then this guy takes care of the database manipulation, okay? So this is a posting from left to right. So your data will be loaded and saved on the database, remote database. At another time, or in our class, there will be another client, which is your iPhone apps, okay? iPhone application receives the data from here. We will have another API, separate API. So one API that is for posting, the other API that is for downloading, okay, from the database. So you can access this, your iPhone app can access this downloading API. Then this guy connect the database and receive the data and send it back to you. Then your iPhone app will display it, okay? Pictorially, it'll be like this. Okay, you have Raspberry Pi and sensors. So sensor, there may be active sensor or passive sensors. Anyway, data can be collected, acquired by Raspberry Pi. Okay. To collect the sensor data, then you need to code, right? That is a Python code. It's a simple Python code. There's no big logic required. Very, very straightforward. Just collect, right? And then we need to call this guy, PHP, in our server, scysql.org, okay? And go there, connected to this API. Then this guy will take care of the data you post to load into the remote database. Okay. So we are here at this stage. So we've done this so far, and we are here at this stage. We just send it up. So after completion of this today's lecture, then I'll ask you to do this posting. This is very straightforward. Once you have this homework, I think it is homework assignment 3, the current homework assignments, right? Then you can add only the few sentences to post. Okay. Evidence that your work can be loaded here in this sensor DB. So next homework assignments, you do not need to I think you can simply say done. Then I will check this database whether your data arrives. Okay. All right. And then we'll work on this later. I'll give you just short introduction to move to this right-hand side today. Okay. This is a database. So I ask you to enter your user name, user ID, simply your text, your name, okay? You should put your name. If you don't put your name, then you don't get credits, right? So you should put your name so that I can see, oh, this guy submitted it successfully. And this is a sensor type, sensor data. Sensor type, maybe if it is a temperature sensor, you can say temperature, or motion sensor, or distance sensor, any sensor, any other sensors, okay? And this is a sensor data. From this type of sensor, data can be collected. So that data fit in this. And then timestamps, current timestamp needs to be printed here. Okay, I think this is, we have some example. I cannot see. Okay, yeah. I think this is a sensor data. This is a sensor type. Yeah, some other data. We'll have an example. This is an address that you can use, okay? scysql.org, JSON, /JSON /sensor/db /sensor2cell db insert.php. This is db retrieve.php. Okay. If you click this, then you can see it already, because I didn't remove the database that has been done last year, so we can see how they work. So if I click, I think I can see some of those. Let me try. Yeah, data already come here. Because, for example, user ID, JUN, DMT11, this is a sensor type, this is data type. So there is a temperature and humidity. That's what D type. It's not D data, D type. And then timestamps, February 20, and then user ID, JUN, oh, wait a minute. And the sensor data is 40 degrees, okay? So this has been done last year. Let's see, let's go to somebody has empty data, sensor type and sensor data. They didn't put, but they have sensor data in this. This first one is, I think, maybe whatever that is, okay? Maybe 20 and 36. Temperature or temperature and humidity, maybe. So instance has done this. So instance did a lot. If you leave this on, then it keeps sending. Don't do that, okay? I mean, maybe maybe 1 minute's enough. Then I have enough data. For example, Campbell send it to me this data. This guy sent it to me April 25th. That time, 41% temperature. That. Okay. Sanchez. This guy is good, right? Sanchez. Sensor type DS18V20, temperature in Celsius and Fahrenheit. And this is data. I think this is pretty reasonable data. Okay. So back to core slide. What is a code? Code is like this. So you need to import a request. And from datetime, import datetime. So datetime is needed. And then sensor database, this is the address. I'll use this Manhattan ones is probably not ready. So SciSecure instead of Sci Manhattan, CySecure. That is what here SciSecure. So use this. And then you feed the data here. And then post to that data. Okay. So you need to run this. So what is needed here is a sensor DB, that address is needed. And then you need to collect the data. This my data, here my data. My data is not hard coded, but this should be from your data. This temperature and humidity, that should be here, okay? And then URL, that is this sensor DB, and data is a collection of all of this in this dictionary type, okay? So data equals open and close curly braces. And then this key should be as is. If you change this key, it's not going to be loaded, okay? So lowercase ID, lowercase sensor, data, timestamps, sensor data, okay? And then this is your data, my ID, whatever your name, and my sensor, you need to put your sensor type. And then data here, this is a sensor type, this is data type. What kind of data this sensor can capture. And then timestamps, and then your data. If you put 20 and 36 as is, then this is your hard coded. Don't do that, okay? You have to collect it from your sensor. Okay. There are security issues between client and API service. Data transmitted, right? In our case, posting then from sensor from client to API. When we have iPhone app, then from API servers to the client, right? Either this way or that way. There may be some spoofing, right? Data may be intercepted and manipulated, and then we send it to the original destination. That is a spoofing. How can we prevent it? How can we detect it, first of all, right? How do you know if this is manipulated and come back to me, right? That's the big issue, especially if that, money related documents, then you may lose financially some, right? Or much. So so what are you going to do in this case? I'm asking you. You can use some of the techniques that you already know. How can you avoid spoofing? In other words, if somebody sniff it, and he may be the data theft, but you want to still keep your value. What is the method?
Encryption. maybe.
Yeah, encryption is a very typical way, right? Yeah, you need to, if you can encrypt it, then at least you may not lose, right? If theft is really clever, technically very strong, then may lose, but somehow we can prevent. What about detection? Do you know if whether it is lost or whether it was manipulated by hackers when you receive it? If you do not know whether it is hacked, then you trust it, and meanwhile somebody already took it away, then that is a big problem, right? So not only the prevention, but also you need to identify, you need to detect it. When you receive it, immediately, oh, something wrong. Let's find out. So how can you detect it? No one can say anything?
Hashing, maybe. I mean,
you are very close to it, right? Hashing. So that apparently, if we use hashing has been used in these days very actively. In what industries? Hash code actively used. In what industry? Anybody can say? Bitcoin, right? What is the price of Bitcoin right now? I think 50K, right? More or less. 50K. I remember
57,000.
57. Who said that? Do you have?
Oh, Monte. Yes, I have some.
Wow, how many?
Half of it, probably. I don't know. I have to check.
Wow. If you have about 10 Bitcoins, then that's 500,000.
I was too dumb not to buy it when it was at $10. So I regret that.
When was it?
Back in 2009, 10, something like that. I don't remember.
10 years ago. 10 years ago.
Yeah, yeah. I didn't trust it.
Yeah, you're lucky. I have 0 Bitcoins. 2 or 3 years ago, one of our students, at that time, he said 2.5 Bitcoins. And then a few days later, he said, I sold out 1 Bitcoin. And he paid back all of his credit card debts and all debts. He cleared up all debits. At that time, it was about, I think, $10,000 or $15,000. Right now, 57. Wow. The hash. What is a long duration transaction? Long duration transaction is not a one-time transaction like this. Left-hand side, that is the one-time transaction. Our sensor data, maybe one-time transaction. I got a cold, right? I need to have water. This is not coronavirus. This is I don't know, corona, maybe? Probably not. I have coughs maybe, well, 1 or 2 coughs every hour, and runny nose maybe 2 or 3 times a day. But there is a long duration transactions. One typical example is this. When you apply the home loan mortgages, okay, home mortgage loans, okay, you want to buy a home, okay. So API services, there's an API services. Loan officers usually request the forms, and some of the forms are posted on some server, right? And ask you to log in and download the forms and fill out and then resubmit it. That type of things occurs. So there's a long transaction. Why? Because so there's one transaction, right? One transaction consists of multiple sequence sub transactions, small transactions. For entire, that is one transaction. So finally, you can say, oh, this transaction is succeeded or failed, right? Fail or success, finally. Short transaction, we simply see in our new homeworks, we can say, oh, successfully posted, done. But that home loan mortgages, they ask you to submit bank accounts and statements, your pay checks, your tax information, and then we request you, hey, give me last 2 years of paychecks, pay stubs, copy of pay stubs. As they review your initial the documents as evidence, if they ask questions, if they want to make sure further, then ask you to submit a little more detailed documents. I think some of you had that experience. I had that experience as well. So there's a long transactions, right? Long duration transactions. If we use a key-based security management, then are we going to use one key for all the documents? Or are we going to use each different keys for each different documents? And while they are moving, I mean, receiving and requesting documents back and forth, and so at some points we lost, okay? Some transaction is thieved. Then this guy did not know whether this guy is submitted, right? And this guy also did not know when whether it is received by the server. So that is a big problem in this whole chain of custody, right? So in that case, particularly, hash is needed, right? When this guy is first send, then using hash and nonce data, and then make it hash and send it to this guy, and this guy can check with the hash if that hash is the same hash that receives, and back and forth. So every time this guy, when this guy send out this guy send out, then the hash chained from the previous hash. Okay, so if I at this point, watch this. At this point, when I send this documents, then I usually check the previous hash. So with this hash, I make new hash and send it. But I supposedly, when I receive this successfully, then this is the previous rather than this. This hash and that hash. I probably use that hash because I didn't receive this. Then this guy says, oh, my previous hash did not include it in this the new hash. Then this guy at that time quickly understands, oh, there's something wrong. Hey, wait a second. We have to redo everything. Okay, at least before the problem becomes bigger and bigger, at some points, either clients or server side may be able to identify, okay, the general ideas. Or key, then you can use this. Okay, then you can maybe use the symmetric keys or asymmetric keys, sample code there. So what happens when you send the data, then you may be able to encrypt this data, okay? Or you may be able to, some of the data, if that is very, very sensitive. But I didn't ask you to, I will describe in your homework assignments of what you need to do, okay? But that is also possible somehow. Okay, the first slide that I posted.